There's a growing movement in the residential sector, mainly stimulated by government incentives, I'll have to admit at this stage, to get that transition and to try and convince householders, who are obviously very tight on budget sometimes, to get them to invest in new technology as required government incentive.
Well, hey there, HVAC pros and enthusiasts. Are you ready to take your skills to the next level? The HVACR Learning Network has just launched an exciting new e-learning course, High Performance Heat Pumps. And guess what? We're giving you free access to the first 2 chapters. Whether you're in the field, training for that next step, or simply want to sharpen your expertise, this course is packed with everything you need to understand and master high-performance heat pump systems, especially inverter-driven cold climate heat pumps. And the best part? You can access it anytime, anywhere, right from your favorite mobile device. It's HVACR learning made flexible and convenient for you. So what are you waiting for? Click the link. Dive into the HVACR Learning Network and start your free trial today. Your journey to HVACR mastery begins here. All right, everyone, thank you for joining us once again on the Did You Know podcast. So we're spending some time with Kevin Stickney looking at solutions and opportunities to relook at geothermal applications. So I'm currently out on the road. I just stopped here in central Indiana at one of our largest wind turbine generation areas. So here just north of Lafayette, Indiana, we have thousands of wind turbines. So we're constantly looking for energy solutions. And there was a time where geothermal energy, geothermal heat pumps in particular, were a solid solution here in the United States. Well, as we increase technology, especially when we start looking at high-performing inverters and just opportunities to relook at technology, we're starting to spend more time focusing on heat pump solutions. So, Kevin, can you tell us a little bit about your background and like the evolution that you've spent in the industry?
Yes, thank you, and thank you for having me. So yes, background in the industry. So mechanical building services engineer, chartered with SIBSE across here in the UK. That's the equivalent of the ASHRAE
Yes.
organization in the US. So yes, I have been practicing building services for longer than I care to admit to be fair. Probably in about 15, 20 years ago, certainly for the UK, that whole sustainability, renewability, eco sort of movement began, and I got interested in heat pumps as in those days the new form of heating. So cutting a long story short, decided to go from general building services and sort of designing buildings, working alongside architects and civil and structural engineers, decided to specialize in sort of using the ground as a source for heat pumps to provide efficient heating and cooling. Since then, been steadily developing. It took us 2 or 3 years in the sort of R&D stage, if you like, to get us technology ready before we were launched into our first building. But yeah, since then we design, we install, we sometimes own, we operate, we maintain, we optimize. So really from cradle to grave, from a project perspective, deploy assets for heating and cooling using the earth primarily as the energy source, but not exclusively.
Sure. We spend a lot of time looking at heat pump solutions here in the United States,
Hmm.
and our ground source heat pumps have really came a long way. Now, we spend
Mm.
a lot more time focusing on those in residential applications in the past,
Hmm.
but we're starting to spend more time focusing on the commercial applications. So,
Mm.
in the UK, what has been that standard? Like, how has that changed, if it has, over time? Are they becoming more um, more acceptable, better received than they have, in the past couple generations?
Yes, yes, I would definitely say it's been slow. Don't get me wrong. I
Mhm.
think anything in the heat and the energy market is slow. Um, but yeah, I think there's a growing movement in the residential sector, mainly stimulated by government incentives. I'll have to admit at this stage,
Right.
to get that transition and to try and convince householders, who are obviously very tight on budget sometimes, to get them to invest in new technology as required government incentive. Um, but businesses have, I think, been a little bit more forward thinking. Obviously they have different budgets and corporate social responsibilities that they have to fulfill. So I think yes, I would say that the sort of commercial side is leading the charge, but
Mhm.
residentially, we're certainly catching up with the number of heat pumps that the government's targeting installation, and yeah, more of these are done. Prices start to come down, reliability goes up, knowledge in the industry goes up, um, and yeah, I think
Mhm.
I think it's a sound investment, and it'll provide good, reliable heat. So
You
become more and
bet.
more popular.
Now, so when we look at, say, the commercial applications, are you seeing more like new construction, or are you seeing system retrofits where we're doing installations, once the building's already established?
Yeah, no, we're seeing a healthy mixture. I think we're
Oh.
seeing new buildings being mandated to obviously think about and provide a solution. Obviously, it's not
Hmm.
not always ground's not always suitable for for every building, but there's certainly new and higher standards for new buildings. But yeah, I mean we work with a lot of clients who have large building portfolios, and that ranges from very well established, sort of red brick university buildings, seats of learning that have been in place hundreds of years. Um, and yeah, I think one of the key drivers in us designing this type of technology that we've got was to be able to retrofit high energy use intensity buildings in
Yeah.
relatively small spaces, because certainly in the UK that makes up a lot of our building stock. High energy use in tight spaces, city centre spaces. Um, so yeah, to be able to provide have a solution that would suit that market, I think puts us in a quite unique and strong position.
Yeah, absolutely. And that's the same kind of scenario that we have here in the United States.
Mm.
We're looking at solutions. A lot of
Mhm.
our older commercial buildings, particularly, especially those mid-size 2 to 3 story commercial buildings, we spent a
Mhm.
lot of times with, gas-fired boilers. We had chillers. We may have had, rooftop package units, air-to-air
Yep.
systems. And so when we start looking at those coefficient of performance opportunities that we have in heat pump technologies, in particular, when we start looking at like geothermal applications, we can significantly reduce the energy consumption of a structure when we start looking at its heat pump opportunities.
Yeah.
So when you start looking at geothermal applications, are you spending more time with like vertical well? Are we doing like horizontal geothermal loop installations? What seems to be the primary installation type that you see in the UK?
We have a range. We specialize in inclined coaxial.
Ah, yes.
So we are coaxial because we want to get higher capacity
Mhm.
than some of the traditional sort of plastic U tubes, and inclined such that we can reach from surface, from relatively small spaces at surface, reach out at an angle subsurface, which is particularly relevant for the retrofit. So where there's an existing building and you might have maybe there's a parking lot, maybe there's a relatively small space available at surface, we can reach out underneath existing buildings and tap into the geothermal potential.
Oh, yeah.
So yeah, that's the kind of technology that we've developed to be able to retrofit these high energy use intensity buildings.
Yeah, yeah, that's very interesting. So when we start thinking
Mhm.
about the, the available landscape that we have underneath of a structure, here in the Midwest, sometimes we do have challenges with depth. We have a lot of limestone and bedrock, particularly here in the Midwest, but many parts of the United States.
Yep.
So, depth of drilling is always a concern. Um, so what type of depth are we looking at with your installations?
So we tend to aim for 200 to 300 meters.
Hmm.
I put that into feet for you, but I've forgotten. But yeah, sort of 200 to 300 meters. That's at the moment our sort of sweet spot.
Hmm.
And again, depending on the application, whether we're looking at a cooling dominated building or a heating dominated building, if it's heated dominated, we might want to go deeper to the deeper end, so we can try and get into that slightly higher geothermal gradient. If it's a cooling dominated building, then we might want to stay a little bit shallower, so
Hmm.
so it's not quite as warm. So again, we're just trying to leverage the right temperature in the earth for the right application that we're serving on surface.
Sure. Now, one of the things that we're really struggling with, I think, here in the United States, as we're going through the HFC phase down. Here at ESCO,
Mhm.
we spend a lot of time doing training and education on our refrigerant solutions, and
Yep.
the from predominantly here in the United States, we used a lot of R-410A for our
Yep.
refrigerant in heat pump applications, even in our geothermal systems. What are you seeing as dominant refrigerant types when we're looking at some of these newer systems?
Yeah, no, that's an interesting question, isn't it? I think that's going to be hitting the markets wherever you are.
Mhm.
To
Yes.
be honest, yeah, I mean, I would say, yeah, even as recent as 3, 4, 5 years ago, it would have been in the in the 410, the 407, the
Yeah.
134A kind of ballpark. Those traditional sort of HVAC refrigerants. Um, but yeah, now we are using and integrating. What are we using? We're a lot of CO2, so
Oh, yeah,
744.
absolutely.
For the right application, we're using propane and butane, so 290.
Wow.
Um, yeah, so again, what we're trying to do, along with all parts of our system, is find the right component to fit within the system for the right application. So
Yeah.
we use CO2. We quite, it's got its good characteristics. It's got its bad characteristics. It can be quite a fussy gas in terms of the temperatures on the secondary side that it likes, and it's high pressure. So you've got safety concerns to look at. And then the same with 290. So 290, where we have those would be more in retrofit applications where we need to reach those slightly higher secondary temperatures, because we're connecting to legacy systems and the fabric's not quite as good, so you can't get sort of the size of heat emitter that ideally you'd want for a lower temperature. So again, R290 is a great gas. Yeah, but it's got its characteristics. It's obviously explosive, so you've got to deal with the ATEX regulations, or
Yes.
making it safe. And there's always ammonia. We haven't used ammonia a lot. Again, it's well used in industrial processes, but once you start to move those sorts of gases into that sort of commercial and definitely the residential space, you've got to be careful. You've got to be
Yeah,
careful.
for sure. And that's
Mhm.
what we look at here as well is, we're looking at what are those alternative refrigerants. We're going to start seeing more of our A2L generations, our R32,
Yep.
R454B. We haven't implemented high enough quantities of R290 to be able to successfully be used in our heat pump applications. We're looking
Mhm.
at that. So ASHRAE is
Mhm.
currently studying, to see what those maximum limits are, and, what is the contact and exposure to, consumers, end
Yeah.
users. And so I
Yeah.
anticipate us to be implementing more of the R290 and CO2
Yeah.
applications here in the near future.
I've got
One
a
other,
290 air source heat pump for my house. So
oh, really?
yeah. So I use that in the domestic setting,
Oh, wow.
and then yeah, we use that in the commercial heat pumps that we put
Oh,
out there too. Yeah.
so
Hmm.
that's very intriguing. So here in the United
Yeah.
States, I'm kind of a bell ringer in our industry. I
Right.
keep trying to work with our educators. We work with about 1,400 schools across the country, so we're trying to keep our educators current with what's happening around the world. And I keep saying that we're less than 2 years away from residential air to water R-290 monoblock systems,
Yes.
residential heat pump chillers.
Yeah.
And a lot of people
Yeah.
think that I'm crazy, and I said, well, we're currently using those around the world very successfully.
Yeah.
And so
Yeah.
if there's another opportunity for us to have a discussion about residential R-290 systems down the road, I
Okay.
would absolutely love to do that, because
Sure.
I'm meeting a lot of resistance here in the United States, and I think that is our solution.
That's how the market goes, isn't it? We
Yeah.
have the same here. There's resistance. There's the incumbents that don't want change.
Yes.
You throw in something like 290 and you get the whole safety fears.
Right.
Yeah, it's overcoming perceptions, but yeah,
Sure.
it's certainly working. I would say, we're not an installer in the domestic market, but the person who installed my personal heat pump in the home, they exclusively do 290. They say it's the right gas for the application. Again, that's sort of retrofitting. So it's a retrofit. So we ripped out the gas furnace and replaced it with a 290 heat pump. Had to upgrade some radiators.
Sure.
But again, here in the UK, it seems to be the refrigerant that's gaining the most traction, I would say, in that kind of area.
Yeah, I believe that as well. One of the things that I was very attracted to when I started looking at your company was like your carbon matrix analysis. Can you tell me a little bit about what you're doing in that sector?
Yes. Yeah. So I mean, that's fascinating. And I must admit, that's not a question that I get asked often, to be quite frank. That whole system carbon content.
Yes.
So I am absolutely fascinated that you asked that in the first place. That's brilliant. But where was that? So that was really back in the day when we started looking at that transition to heat pumps.
Yes.
And looking around in the market, people are saying, well, you've got to decarbonize, you've got to get the carbon out of your heat, etc., etc. And the question is why. And once you've answered that question, the question is how. So we were seeing at that time a lot of a wide range of different technologies and the same technologies saying, switch to me and your carbon content will drop by this much.
Right.
But it was very difficult to get, as an engineer, you then try and dig into that and look at it. So, well, how are you doing that? Does that stack
where's
up?
the data? How do we
Where's
validate
the
this?
data? Absolutely. Where are the references for those data points that you've picked?
Yeah.
And and certainly in the UK, and I'm pretty sure it's the same in the US, the regulatory figures that we have to use when planning new systems is very far behind our electricity market. So wind and solar have overtaken in terms of generation, so that's pulled down the carbon content of electricity. But our regulation, which is or was, because we're reforming that a little bit better now, but was, let's say, 5 years behind the market. So when I was designing a new building now to last 25 years into the future, I had to use regulatory figures to prove my carbon content that were 5 years out of date.
Oh, wow.
So we were looking at that and thinking, right, so that's a problem with the regulatory. But also, how do I describe my own carbon content? Because I'm sure you'll know, right? So you've got grid electricity, which fluctuates every 5 minutes as to what the contribution is to that grid. You've got your heat pump, which can vary in terms of its efficiency every 5 minutes, so low loaded, high loaded, high COP, low COP, and different amounts of heat. So if it's first thing in the morning, you've got a terrible COP at a high carbon content off the grid. That's one set of factors. But then you run it for the rest of the day, your heat pump at the rest of the day, a lower load, higher efficiency, grid carbons change. So there were three very dynamic factors within actually working out what the carbon content of our heat was. So what we wanted to do is say, well, can we pull all that data together into one place, into the same sort of timestamp, and then do a calculation to work out at that specific chunk of 5 minutes for us, what heat did we generate? What electricity did we use to generate that heat? What was the carbon content of that electricity? Again, off the grid, off of our standard UK-wide grid. And there are so many grids, again, so many different grids within grids. So there's arguments about what factor you take, but staying to that. Put those all together and then really say, right, actually, that was the carbon that we used to generate that amount of heat. which means our carbon content of heat was this. And what we found, even 5-10 years ago, is that we were 50% better than the regulatory figures
Wow.
that we were using. So since then we have been tracking that. So every 5 minutes we get the data from the electricity grid to say what generators contributed. So nuclear, wind, solar, gas. We haven't got any coal anymore on our grid in the UK, so that's a plus. Imports and exports from France, from Europe, from Norway, from Ireland for us. Putting those all into the mix as a 5-minute pot, and then because we operate and maintain and optimize our systems, we also get our data. So that allowed me to amalgamate them, to do the sums, and then we can display that figure on our website. We display it every 5 minutes, so it changes every 5 minutes. So we're usually about half hour to 45 minutes behind, because we've got to pull the data in, we've got to do the sums.
Got to calculate it. Yeah, absolutely.
Got to calculate it. But that allows us to do a 5-minute chunk, which I think really allows people to see the sort of the dynamic nature of how a heat pump works. So sometimes in the morning, your COP will be 3.5, 4. Sometimes in the afternoon, you're talking about 5 to 6 COPs, and the grid fluctuates as well. And then over time, gathering all of that data has allowed us to amalgamate it, and and also then get that sort of annual average. So at the moment, our regulatory figure is somewhere in the 225 grams of CO2 mark, but through gathering and analysing this data, we know that our figure right now for heat is closer to about 30 grams of CO2 for every kilowatt hour. So we can confidently say to our clients, well, this is how we've actually reduced, your carbon content,
your carbon footprint. Yeah.
Yes.
As well as your energy use.
Yes, exactly. Exactly.
Wow,
Exactly.
I absolutely love that. So I'm kind of a geek and a nerd in our industry, and for me, data is the only thing that we can use to, validate performance.
Yes.
And when you're using calculated data like that, we're actually showing not only our energy reduction, we're showing the reduction in our carbon footprint. And so when together we can start looking at that, and we can understand our own impact for energy consumption. It's brilliant.
Yeah. It's quite, and again, looking at then when you're starting to look at those numbers, and then we go back and analyze it and say, oh, right, there's a peak in energy use, so COP was low, or there's a peak in carbon. How can we then adjust how we would use our heat pump, to get us out of those periods of high carbon, or to get us out of those periods of high cost, or out of those periods of low efficiency? So again, looking at those numbers, allows us to go back and analyze it. So we can ask ourselves, what could we have done differently? And again, that's where using the ground is really special, because if we want to get a better efficiency at a certain time in the day, then we know we need to load that ground with energy to store and to be available back to us, at that different time when we really need it. So again, firstly calculating that data, and then allows us to analyze it, and then it allows us to make better acts, better controls, better solutions.
Better management and algorithms for our controls. Wonderful. Well, Kevin Stickney, I really appreciate your time. Where can we learn more about this data so we can actually see some live calculations of all of this that we've been discussed?
Yeah, you can see that on our website. So again, because we own and operate buildings, I can gather all the data. We anonymize it, so I'm not telling you, whose building does what, but we gather it on our website. So that's urdaenergy.com. If you go to our insights page and scroll down, you can see a chart showing the 5-minute data. You can see our actual data versus a simulated. You can use either gas or oil. And here in the UK, you can put yourself in the English grid, or the Welsh grid, or the Scottish grid. So you can pick different grid carbon emissions. And then keep scrolling down, and you'll see how that's tracked over time. So you can do a comparison for the last month, and I think the last 3 years. So you can see how that's tracked.
Very cool. I love it. I will absolutely have to spend some time diving into some of your data. I encourage everyone to take a look at the website, get a little bit more familiar with, analyzing energy cost and consumptions. And I really appreciate your time hanging out with us today.
Well, thank you. Thank you for the invite. And thank you for the question. Like I said, fascinating question.
Yeah, it really is. Yeah, this is the kind of stuff that I enjoy having conversations on, helping people get outside of their comfort zone and have a better understanding of our own carbon footprint. And without
Yes.
data, we don't have, concise analysis. So I
Yes.
really appreciate the effort that you put into that.
Well, thank you, and you're welcome. And you're welcome. Yeah. So happy reading on the website. Don't track it all day.
Right. All right. Well, thank you very much for your time, and we
Good.
appreciate you joining us today on Did You Know, the ESCO HVAC podcast.
Thank you. Thank you. Have a great day.